Hello everyone, welcome to my presentation. This presentation is recorded by my side. My name is Abdurrahman Basalan and I'm recording this video for my CS 898 CD Introduction to Trusted Computing final project presentation. First of all, I'm so sorry about the deep noise. I couldn't fix it, but I hope that everyone's clear my voice properly. Alright, let's start with the contents. So for the final project, we are required by our instructor to read 4 different papers by 4 different areas, and I already read these 4 papers, which are named respectively Hypervision Across Worlds, Real-Time Kernel Protection from the ARM Trustzone Secure World. The second one is Using ARM Trustzone to Build a Trusted Language Runtime for Mobile Application. The third one is TrueSense Information Leakage from Trustzone. The fourth one is TEE Check, Securing Intravehicular Communication Using Trusted Execution. And once I present these 4 papers, we will have the conclusion. Let's start for the first paper, and I'm gonna share my knowledge with you. Okay, as I mentioned previously, the first paper is Hypervision Across World, Real-Time Kernel Protection from the ARM Trustzone Secure World. So we have like some small description about each line. The first one is the main problem that we covered. Attacks that conspire the OS kernel still pose a real threat for both normal world and secure world. And the key research question is how attacks can get permit on system and catch sensitive data, hide malicious activities, and change the OS behavior, or simply take control of the system. The main idea is secure world infrastructure about how they can make more safe for system, which they call Trustzone based real-time kernel protection, which provides the basic architecture required to protect the OS kernel using a security monitor that is entirely located within the secure world of ARM Trustzone. It's the good way to both durable and possible isolation from potential attacks. It also completes 2 important objectives. First of all, it completely protects running unauthorized privileged code on the target system. And another important achievement is that prevents kernel data from being directly accessed by user level processes. The main approach they use security issues on kernel layer is Trustzone based real-time kernel protection, which provides the basic architecture required to protect the OS kernel using a security monitor that is entirely located within the secure world of ARM Trustzone. And so here we can see that the secure world and normal world, how do they communicate each other? The control instructions and page table update functions are replaced by traps to the secure world, which we can see from normal worlds and transmitting to the secure world. And the secure world transmit to normal world as page tables are mapped read-only, so they cannot be directly modified by the kernel. So in any cases, the attackers can reach out to normal world, and they have to get the permission and the other sensitive information, and then they can execute to the secure world, which we can see. However, as we can see from here, secure world is protected by the Trustzone based real-time kernel protection. And how we can say here is The important open research question is an attacker can change the location of interrupt handlers to create invisible hooks that hijack the kernel's control flow, which is another issue for the following research topics that we can say. But as we see here, so we literally can understand that how the communicate normal world and secure world, and how the trust zone based real-time kernel protection is working. Okay, the second paper that we have is using ARM Trust Zone to build a trusted language runtime for mobile application. So I'll just explain briefly about the problem and idea and approach here also. The main problem is that mobile applications which you can make, purchase, or keep your sensitive data open a tremendous attractive target for attacks through using mobile phones. So this is the important part, because in addition to these information, photos, location tracking, or online banking information have a high value to spammers and identity thieves. And also trusted computing based code that mobile maps depend upon is very complex, that we can say, which is another problem. In contrast to the main idea, that we can say trusted language runtime, which is small runtime engine capable of interpreting .NET managed code inside the trusted environment. While adding this runtime raises the trusted computing base size, the trusted language runtime is properly crafted to avoid a bloated trusted computing base and keep it significantly smaller than a full-blown .NET framework and full-featured operating systems. The main approach is small trusted computing base, easy of programming, compatible with legacy software environments. So what does it mean actually that we can say? Allow application developers to factor out the security sensitive application logic into classes that transparently run in a trusted environment. And so, in other words, isolate the trusted language runtime and the trusted application code from the bulk of the system software by using ARM Trust Zone technology, and borrow parts of the runtime engine designed from the .NET Micro framework, which is a small .NET implementation designed for embedded devices. So those are the important parts for approaches in terms of execution of the trusted language runtime. So we can see that here that how the trusted language runtime works. As we see from the normal world, .NET applications are working on operating systems. They are communicating each other. The first one, the attacker is coming to the .NET app and leaking with the operating system. They are finding some hiding places on the operating system and then trying to leak into the secure world. But thanks to their trusted language runtime, the trusted instance, as we see the trust box, they are including the sensitive data for the users, whoever they have the sensitive data, which is protecting the users' data from the attackers. Even though they can leak into the secure world, the trusted language runtime is protecting all the data types inside their trust box. Okay, the third paper is True Sense information leakage from Trust Zone. The main problem here is while secure containers such as I'm sorry, my microphone is making some problem. Anyway, while secure containers such as Trust Zone are effective in providing separation for computations, information leakage via side channel remains a challenge. There are multiple versions of the attack types, such as denial of service and distributed denial of service, and so on. The side channel attack is another problem on these things. In this study, the authors concern on side channel attacks target information leakage of a physical implementation through its interactions with the execution environment. Even though side channel information can be acquired from different types, authors can address cache-based timing attack is one of the most important areas of research. The main idea they are bringing is TrueSense exploits the cache contention among the normal world and the secure world as a cache timing side channel to extract sensitive information from the secure world. Uh, as I mentioned previously, like the users are keeping their sensitive data, which is important part, but the trust zone is effective in providing the much needed memory isolation, and that's why authors believe that it's possible to derive secret information from secure world using the cache contention because of its high performance cache sharing design. With the light of this information, their idea named TrueSense to study the timing based cache side channel information leakage of trust zone. TrueSense is not only providing the launch for normal world operating system but also a non-privileged user application. TrueSense is also working without access to virtual to physical address mapping in user applications, which uses the expected the channel statistic to allocate memory for cache probing. The main approach that we can talk about, they are identifying the side channel information leakage from the design of dynamic cache allocation with TrueSense, severity of the information leakage by implementing and testing the proposed side channel attacks on a hardware platform. The TrueSense is not only working for the hardware platform but also working effectively on the software side. That we can say the leakage happened because of fundamental design choice of the trust zone enabled cache architecture, which aims to improve system performance by allowing two worlds to share the same cache hardware, that we can say. And another approach is unprivileged user space application can launch side channel attacks on trust zone, which is some important part for this study. And on this figure that we can see that the normal world and secure world communication again. The victim is trying to leak into the normal world through using the user's interface, and they are getting the privileged side that we can see. The trust zone driver is communicating with the secure world and monitoring all the data types and what's happening in terms of exchange the data. And Trust Zone Service Manager is connecting with OpenSSL, which is keeping our data properly over there. But thanks to their TrueSense technology, I mean they are dividing the user privilege or non-user privilege, and they are keeping all the attacks and all the leakage on normal world, which means they are keeping the secure world properly. Okay, our last paper is TEE check securing intra-vehicular communication using trusted execution. The main problem is an attacker may compromise an ECU to gain access to the bus. ECU is the electrical controller unit. Because of this, the obligatory thing is that the controller area network bus is secured from disruption by compromised ECUs to ensure its correct and timely operation. The main idea here, we can say that propose a new design system architecture for ECUs that leverages trusted execution environments and propose TEE check. On this study, authors propose the new designed system architecture for ECUs that leverages trusted execution environment, considering the large amount of data on the controller area network bus, has become a lucrative target for malicious parties wishing to take control of vehicle. Because of the vehicles are going to be autonomous or unautonomous, and all the sensors are actuators are increasing dramatically on every vehicle, so some of the electrical control units and controller area networks are going to be more problem for the vehicle owners, because in terms of the safety of these sensors, it keeps us from the avoids the some accidents and our safety things. The main approach here is electrical controller unit to utilize trusted execution environment capable processors which allow code division, making it possible to verify controller area network message source and destination within an ECU itself instead of at the receiver ECU. The second approach that we can say that TEs are isolated execution environments designed to run trusted software, and they are supported by processor architecture extensions which include strict access control policies to processor components, peripherals, data, and address buses. Okay, on this figure that we can see that the regular ECU system, so the regular ECU system is dividing all tasks properly and using the sensors and actuators, and the controller area network is communicating these tasks each other properly. So which is the very simple and basic system, and that's why the attackers can leak into this system. However, on part B, which means on the right side, we can see that ECU system utilized for TE check. The controller area network controller is connecting with the secure world directly. They request source verification from the non-secure world, and we have the transmission among these non-secure and secure worlds. And the sensor and actuators are communicating with the non-secure world also, and all the tasks are not connecting with the secure world directly, which is keeping us safely while we are driving on the system. And for that part, the controller area network message checker, there is two important part here that we can say is transmission and reception. The transmission part is using a two-stage pipeline, one stage for message source verification and another for message frequency enforcement. The reception side doesn't allow ECUs direct access to any messages which pass the CAN controller message filtering stage and which are made available for reading. Okay, we can see another transmission and reception side for the TE check section. So as we see for the middle part, the non-secure callable part, which is working for the transmitting and the communication between each other. And so all the parts are, the secure world is checking all the data types and all the requests properly and sending the messages to the non-secure world. If there is any information except for their knowledge, so it's gonna be deleted immediately. Okay, the conclusion part. As we understand from these papers, all the trust zone applications have security breaches and they need security improvement. And both hardware and software sides are studied much well by researchers in terms of trust zone implementation. Secure world is the most important part for keep sensitive data, because all our important data are kept by secure world. Normal world should be strong and more awake in terms of who is involving in normal world. That means the attackers are involving with the normal world first time. So that means the normal world should be tracked properly and respectively. And attacks are changing day by day, and algorithms need to stay updated every day. So thank you so much for listening my presentation. If you have any questions, you can contact me through my email address that I mentioned on this presentation. Thank you so much for everyone.